All right, good morning, Calculus 2 people. So we're going to continue working on our pretest here, and we are looking at problem, I think, 3B. So let's go ahead and double check. Yes, 3B. So we're going to figure out the surface area, okay, for x equals 2/3 y over 3/2, okay, right over 3/2, between y equals 0 and y equals 3. Okay, so with surface area of revolution, you have a choice. Okay, I need to write this down, but we had a choice. We could say that this is either going to be the with revolving around the x-axis here. Okay, so revolving around the x-axis. You have a choice. You could say that we have this little slice here. We're going to get our radius, and then we've got the surface area. So we're going to take this little sliver here and rotate that around. Okay, so that's the idea for surface areas. We're just pulling this little ds out of here to do this. So we have a choice. And the choice is you could either set this integral up as a to b, 2 pi f of x, and I'm just going to leave it as ds because the little tiny piece of surface or arc length here could be expressed either as integral with x or with y. Okay, it doesn't really matter which one you pick. Well, it does matter which one you pick, but you want to pick it so that things are going off. So this is going to be f of x. Or we could pick this from c to d as a 2 pi y. You say, well, isn't y equal to f of x? Like, yeah, it is, but we get to choose which version or which kind of iteration we want to see of this radius. We can either express it in x's or we can express it in y's. It's still going to be in y, but we can say either y or f of x depending on how the problem is set up. And again, ds. Since this problem is screaming y at us, right? Why don't we pick this do it in terms of y rather than x? So what we're going to do is we are going to go ahead and set this integral up from 0 to 3. We have a 2 pi y, and then our value, so our surface area is going to be 1 plus, instead of dy by dx, we're going to say dx by dy squared, okay? And then we're going to have our dy at the end of this thing, because everybody's in terms of y's, and that's how we're going to go through and do this, because we're not taking a little piece of x's and rolling it around. We're taking a little piece of surface area and revolving it around. Okay, so it's a little bit different than the washer method. Okay, we're not really dealing with a radius. We are dealing with a radius, but we're not dealing with a volume of revolution. This thing is hollow. Okay, so we're dealing with this surface area. We're dealing with this arc length and rotating that around. The radius is going to be the y or f of x, kind of depending. So we're going to pick the version that is screaming y at us rather than try to force this into something with x. I know x is like more comfortable, but we are allowed to do this with y's as well. And this problem, because it has so much saying, oh, well, you should probably use y, we're going to make that choice, and we're going to go ahead and make y for it. So in order to get dx by dy, okay, we're going to go ahead and say, well, actually x equals, let's go ahead and make that clear. So we're doing this like organized. Okay, so we're going to say x equals 2/3 x to the 3/2. 2/3 y rather to the 3/2. Okay, there it goes, force to have it. Okay, and now I'm going to go ahead and say, well, I want dx by dy, which is backwards. I know it's weird to write that, but the 3/2 comes down in front, cancels off with the 2/3, and we end up with a y to the 1/2. Now we have to go ahead and square this thing, which is just going to be y, and then we're going to go ahead and add 1 to it. So my surface area, my ds, is equal to 1 plus y all under a square root. All right, so that's the whole business there. Now I'm going to go back and plug it back into this formula over here. Okay, so we're going to have our 2 pi 0 to 3. I have y square root 1 plus y. Now, you may not have seen this trick. We teach this trick a lot in Elements of Calc 2. Actually, Elements of Calc 1 a little bit, mostly in Elements of Calc 2. We teach this trick a lot when you have like linear terms times other exponents. Okay, so we're going to go ahead and uh, set u equal to 1 plus y, meaning that y is equal to u minus 1. Okay, so we have that. I'm going to go ahead and say from here, when y is equal to 0, u is equal to 0 plus 1, 1. When y is equal to 3, u is equal to 4. So we're going to go ahead and change our limits of integration here. So I'm going to have 2 pi integral from 1 to 4. What the heck was y? Y was, it looks like u minus 1. Okay, and then we have 1 plus y inside of my square root. So I've got the square root of u here, or u to the 1/2. And then all we're going to do is distribute. So let's go ahead and change that to u to the 1/2. So we're going to say 1 to 4. Now we're in u world. We have u minus 1 times u to the 1/2. There's nothing preventing me from distributing this term to this. If there's no pluses in here, and there isn't, then we can just multiply these exponents and deal with it that way. So we're going to have 2 pi integral u to the 3/2, right? 1/2 plus 1 minus u to the 1/2. And again, we're going from 0 to 4. And now we're in the u world. So we just end up with the u here. Okay. So go ahead and integrate. So this is going to be 2 pi. We have u to the 3 plus 2 is going to be 5/2. We have a 2/5 out here. Minus, we have a u to the 3/2. We have a 2/3 here. And we are going from 1 to 4. And I think this is going to go ahead and finish off our integral for us. Okay, so we just plug these in. 2 pi. We have a 2/5 times 4 to the 5/2. That sounds delightful. Minus a 4 to the 3/2. Okay, and this was you evaluated at 4. Minus, let's go ahead and we're going to multiply this whole thing by 2 pi. And then we have 1. 2/5 raised times 1 to the 5/2. That'll be easier. Minus 2/3 u to the 1 to the 3/2. Go ahead and put brackets around these guys. This was u evaluated at 1. And now that's over, but for the arithmetic. Okay, so we just have that. So we have 2 pi. Okay, and then nobody's going to watch the rest of this thing. We have 2/5 times 4 to the 5/2. Let's see, the square root of 4 is going to be 2. 2 raised to the 5th power is 32. Minus 2 raised to the 3rd power is 8. Oh, wait, it should be a 2/3 in here. Don't forget that. Okay, and then there we go. Minus 2/5 minus 2/3. Okay, because the ones were easier. You guys have a calculator. I am sure you can figure out the rest of this, but but for the arithmetic, this is the answer. Okay, so I'm not going to bore you with getting common denominators and dealing with the fact that I've got to kind of futz through this thing. But that's how you do this kind of a problem. Again, way at the beginning, you have a choice. You can either write this as f of x ds, and then of course you could choose which ds you want to use. Is it 1 plus dy by dx squared dx, or do you want to choose 1 plus dx by dy, 1 plus dx by dy squared times dy? So you have choices how you're going to do this. Since this one is screaming, please use y's, we're going to use y's. Okay, and that's how we're going to go through and get this problem done. Okay, so I hope that was helpful for everybody. Good luck on your exams and study hard, and I hope to see a great performance from everybody. Thank you very much for watching.